So hello there. One of your classmates sent me some great questions about the last test, the test where you had to write the dog class. And I thought I'd go over the questions for all of you, because if one person has these questions, the odds are that others of you do too. Some of the questions are pretty straightforward, but some get into some really interesting issues with Java and programming. So let's start with the first issue, which was about primitives versus objects. So we have three fields here. Right? Fields are variables that are declared outside of any methods. They're usually declared at the top of the class, and they are accessible throughout the program, which is, throughout the green area in the background here, throughout the class, I should say. All right, so primitives. Primitives are called that because they're very simple data, right? They're like unitary. They're all of one piece. So examples, an integer, right? You can't break an integer down except into another integer. So it's primitive. Think of it as like primitives being the most basic types, right? So an integer variable, an int, is as basic as you can go. A char, a single letter, character, it doesn't have to be a letter, it could be any character, like an exclamation point. That's as simple as you can go. You can't break it down further. You can't have like a half exclamation point. Same with double, which is a whole number, versus an integer, which is when I say a whole number, I mean a number with a decimal point. You can't break it down except into another whole number. And the fourth type of primitive is a Boolean, right, which is either true or false. So you can't break that down either. It's either true or it's false. You can't have half true or half false with programming. In the real world, sometimes things get gray, but in programming, no. It's either true or false. So those are what primitives are, right? But these very basic data types. Objects are more complex data types, and they often have within them numerous of the primitive types. So for instance, the string class, an object of the string class will have in it many chars, right? If the word Spence is stored in the string name, then that string object has 6 chars in it, right? So it's built up, objects are built up out of the primitive types. And so they're less basic, so that's why they're not called primitive. They're evolved types, okay? So that's the big difference between objects, classes, which are just the definition of objects, and primitives. I hope that's clear. Okay, second question had to do with parameters and variables. So within a Java class, variables have different scope, meaning they're accessible to different degrees. The variables declared up here, the fields, as I call them, you will also see them called instance variables, right? Because each instance of the class gets its own copies of these variables. If we make 3 dog classes, 3 dog objects, then there will be a total of 9 of these variables, 3 of age, 1 for each dog, 3 of name, 1 for each dog, 3 of gender, 1 for each dog. So for each instance of dog, they get their own set of these variables, right? But these variables are accessible throughout the class. So anywhere in the class, we can use those variables, and Java knows about them, and whatever their content is. Right? You can think of it within this green area. Parameters, which are the variables used to hold information that you send into a method, their scope is only within the yellow area, which represents the method, right? So only when this method is active, only when the computer is executing the statements in this method, do these variables actually have value and meaning. Outside of this method, as far as Java is concerned, they don't exist. Whereas these fields exist throughout this class, so it doesn't matter which method is running, these variables are all active and accessible to all the methods, whereas these are not. Now, why do we have to have a name for these variables, the parameters, that is different from the field name, right? Well, here's the deal. If I change that to age, Java thinks you want to create a different age variable than this age variable. An age variable that will only be active within the method and will have its own value separate from this age variable out here, the field age. So when I say Java gets confused, it doesn't really get confused. What happens is that it thinks it has a second variable called age, and that variable will, if we come down here, what you're meaning to do here is set this variable age equal to this age parameter that you passed in. But as far as Java is concerned, both this age and this age refer to this variable, right? And remember when I said the parameters sort of cease to exist when the method is not executing? That would mean that when this method is done, age would not have been set, the field age would not have been set to what you wanted it to be set, right? Because it was never accessed. It was never, the program was never using that variable. It was using this local variable age, which was gone when the method is over. So that's why we have to have a different name so that Java doesn't think we want to create another variable with the exact same name as this. It'll let us do that, but they're two different variables even though they have the same name. The local variable exists within the method, the field exists out here. But if we use the local variable name, age, we need to change this back, it will think we're talking about the local variable, not the field. Okay? Not a good thing. So that we have to take care of that. Oh, by the way, variables declared within a method, so I declare a method in here in wait, for instance, that's a local variable. It only exists within this method. And as soon as this method is finished, wait no longer exists as far as the rest of the program is concerned. Okay? So local variables, variables declared within methods, and parameters, which you could also think of as being variables declared within a method, they're just declared in this special place so that we can use them to pass information into the method. They only exist as long as the method is active. Right? Okay. Methods versus fields. So, right, what's in the yellow box are our methods. These are program statements to accomplish some task. Methods use fields. That's where the information that's acted upon is stored. But methods are different from the variables, actually. Obviously, right? So when we compile this, and we make a dog object, and we'll give this dog an age of 12. Let's say its name is Fido, and we'll say it's a female. Okay, so those are going in. Those values are being sent in. As soon as I click OK here, 12 is going to go into the age temp parameter. Fido is going to go into the name temp parameter. F is going to go into the gender temp parameter. Right? So we're sending this information in to the constructor when we make the dog object. So we're giving the dog object state. The state of the dog object is that the dog is 12, its name is Fido, and it's female, right? And it's these assignment statements that move that information from the parameters over to the fields, where it will be stored as long as the object exists. Whereas these guys will cease to exist as soon as the constructor is over, right? The constructor's done its job. These local variables no longer exist within the dog object, right? Only the fields do. Okay, so I click OK here, and my dog object is created. And here are the methods, right? The constructor doesn't show up because the constructors run automatically when you make an object of a class, right? You can't call it again. It's only called when the object is created. So those are the methods of the class, right? Now I can inspect the class. When I inspect the class, I can see these are the fields. Those are those three fields at the top, right? And even though we're not running a method right now, none of the methods are active, these fields still have values. And we'll hold values as long as the object's in existence, right? Okay, cool. So back to the code. What does it mean what do I mean when I say a method returns something? Okay. Most of the time, as our programs get more interesting and complex, what we'll be doing is creating multiple classes that talk to each other. That's what this latest assignment does, right? When we start out in programming, to make things easier, instead of having one object of a class talk to another object of a class, basically we take the role of an object of another class, and we interact with our class, right? So when I say a method is void, it means that when I interact with the print dog info method, I don't expect this method to return to me, right? I'm acting as taking the place of another object, talking to this dog object. I don't expect it to return anything to me. I expect it to just print the dog info. That's why it's declared as void. Now say I wanted to instead get back the dog's age. In this case, it's going to return to me an integer, right? Get age. This is from the very first beginning, right, of when we started with Java. This is a accessor method. It accesses a field. So we don't need to pass anything into this method. That's what, if we did, we would put it inside of these parentheses. And what we want to do here is to get returned to us the dog's age, right? And again, remember, in real-world programming, it's one object, another object, asking the dog object to give it to return the dog's age, because that other object wants to do something with it, right? So it's a little artificial that it's returning it to us, but you should be able to get the idea that we're just, again, taking the role of another object within Java, interacting with this object, okay? So, okay, so that is the entire method. That compiled without a problem, good. So we have to make a dog again. We have to go through all of this, 23, spot, and we'll make him a male. Okay, now I can call that get age method, and then notice it returns an int. It says int here as opposed to these that say void, because they don't actually return anything. But this one returns something. And in this case, remember, I'm taking the role of another object, so it's returning it to me. It's showing me that the dog's age is 23. Okay? Another object, if another object were getting back this information, it might do something. It wouldn't ask for it unless it was going to do something with the dog's age, right? So you might have a program that has a bunch of dog objects and it's looking for dogs of a certain age. So it can ask each dog, hey, what's your age? The dog returns its age, dog object returns its age, and the program, based upon the integer value that it gets returned to it, makes some decision or does something. So in this case, this is values being returned to us, and great, it's interesting, the dog's age is 23. But that's what it means to have something returned, right? It means that a method of an object gives back, returns a value to something else, in this case, us. All right. Okay, parentheses. There are three different ways that parentheses are used. One is to enclose parameters, right, in the first line of a method. You always have to have the parentheses there, even if you're not sending any information into the method. They need to be there, right? That's one way. Another way is in print statements, right? Whatever it is that we're printing is enclosed within parentheses. It's a different way we use parentheses. A third way is in if statements or while statements. And basically what we're enclosing within the parentheses here is what's known as a Boolean condition. It's a condition that evaluates to either true or false, right? So whatever's between the parentheses after the if or the while needs to evaluate to true or false. That's the third way. And I think there's also, you use them in for loops. It's the fourth way. Now, those are the only ways I can think of right now. There may be others. But, and then you'll notice here in this if statement, the purple is used just to determine the extent of the if statement, right? So you can see really the if statement is this whole thing, including the else, because they always go together. If you're using an else, you don't have to, but if you're using an else, that else is part of the if statement. So the whole area has this purple background. Just as a visual clue to you, that's the extent of the statement. You can see the same thing down here with the while statement, right? Everything in the while statement, including the first line, is enclosed within this purplish background. Again, it's just a hint to you, the programmer. Now, another question relates to the use of the braces. These are the braces, right? So here's the rule. The braces are essentially there to tell Java the things that you're supposed to do within something. So methods have braces to say, okay, between here and here, that's all the statements in this method, all the commands in this method, right? That's it. They're used to delineate that. Same thing here, right? If we use the braces here to say, what statements do I want Java to do if this condition is true, right? I don't have braces here because I only have one statement. If you only have one statement, you don't need braces, right? You can just leave them out as a shortcut. You can put them in. We only have one statement here. It doesn't do any harm, but you don't need them. But if you have two or more statements, you definitely need braces to tell Java, hey, these are the statements that I want you to do in this situation, okay? So in the while statement here, we have two statements, so we have to enclose those within their own set of braces so that Java knows these are the statements that I want you to do as long as count is less than how many barks, okay? Cool. Another question, can we determine how many times the dog barks? Well, that's in fact the way this method is set up, right? We pass in as a parameter how many times we want the dog to bark. And then we set count equal to 0, a local variable, count equal to 0. And then within this loop, we increase count every time we go through the loop, right? And we bark. And we keep increasing it until count is equal to how many barks. So if we call bark, right, and it's telling us we need to pass in an integer. So we'll pass in, I don't know, 25. It's a very noisy dog. So that 25, as soon as I click OK, is going to be sent into how many barks. So then within this method, how many barks will, as long as this method is running, how many barks will be equal to 25, right? And it will, excuse me, will bark 25, right? Bark 25 times. So I think those are the main questions that were covered, that were asked. I hope my going over this was helpful. If you still have questions, ask them, okay? Thank you.